Good morning, students. Let us continue with the next topic of chapter number 15, biodiversity and its conservation. Next topic is patterns of biodiversity. First is latitudinal gradients. The diversity of plant and animal is not uniform throughout the world but shows rather uneven distribution. For many group of animals or plants, there are interesting patterns in diversity. The most well known being the latitudinal gradient in diversity. In general, species diversity decreases as we move away from the equator towards the poles. With very few exceptions, tropical latitudinal range of 23.5 degree north to 23.5 degrees south harbor more species than the temperate or polar areas. Colombia, located near the equator, is nearly 1400 species of birds, while New York at 41 degree north has 105 species and Greenland at 71 degree north has 56 species. India, with much of its land area in the tropical latitude, has more than 1200 species of birds. A forest in a tropical region like Ecuador has up to 10 times as many species of vascular plants as a forest of equal area in temperate region like a Midwest of USA. The largely tropical Amazonian rainforest in South America has the greatest biodiversity on earth. It is the home to more than 40,000 species of plants, 3,000 of fishes, 1,300 of birds, 427 of mammals, 427 of amphibians, 378 of reptiles, and of more than 125,000 invertebrates. Scientists estimate that in these rainforests there might be at least 2 million insect species waiting to be discovered and named. What is so special about tropics that might account for their greater biological diversity? Ecologists and evolutionary biologists have proposed various hypotheses. Some important ones are: first, speciation is generally a function of time. Unlike temperate region subjected to frequent glaciations in the past, tropical latitudes have remained relatively undisturbed for millions of years and thus had a long evolutionary time for species diversification. Second is tropical environment, unlike temperate ones, are less seasonal, relatively more constant and predictable. Such constant environment promote niche specialization and lead to greater species diversity. There is more solar energy available in tropics, which contributes to higher productivity. This in turn might contribute indirectly to the greater diversity. Next pattern is species area relationships. During his pioneering and extensive explorations in the wilderness of South American jungles, the great German naturalist and geographer Alexander von Humboldt observed that within a region, species richness increased with increasing explored area, but only up to a limit. In fact, the relation between species richness and area of wide variety of taxa turns out to be rectangular hyperbola, as shown in the figure. On a logarithmic scale, the relationship is a straight line described by the equation log s is equals to log c plus z log a, where s is species richness, a is area, z is slope of the line, c is equals to y intercept. Ecologists have discovered that the value of z lies in the range of 0.1 to 0.2, regardless of the taxonomic group or the region where it is. The plant in Britain, birds in California, or mollusk in New York, the slopes of the regression line are amazingly similar. But if you analyze the species area relationship among very large areas like the entire continent, you will find that the slope of line to be much steeper. Z values in the range of 0.6 to 1.2. For example, for frugivorous, that is fruit-eating birds, and the mammals in the tropical forest of different continents, the slope is found to be 1.15. Let us see the graph, species richness versus area. If the straight line is there, then log s is equals to log c plus z log a, while S is equals to CA square for the curved graph. Next is the importance of species diversity in the ecosystem. Does the number of species in a community really matter to the functioning of the ecosystem? This is the question for which ecologists have not been able to give a definitive answer. For many decades, ecologists believed that communities with more species generally tend to be more stable than those with the less species. What exactly is the stability for a biological ecosystem? A stable community should not show too much variation in productivity from year to year. It must be either resistant or resilient to occasional disturbance, natural or man made, and it must also be resistant to invasions by alien species. We don't know how these attributes are linked to species richness in community, but David Tillman long-term ecosystem experiments using outdoor plots provide some tentative answers. Tillman found that plots with more species showed less year-to-year variation in total biomass. He also showed that in his experiments, increased diversity contributed to higher productivity. Although we may not understand completely how species richness contributes to the well-being of an ecosystem, we know enough to realize that rich biodiversity is not only essential for ecosystem health but imperative for the survival of human race also. At a time when we are losing species at an alarming pace, one might ask, does it really matter to us if a few species become extinct? Would Western Ghats ecosystem be less functional if one of its tree frog species is lost forever? How is our quality of life affected if, say, instead of 20,000, we have only 15,000 species of ants on Earth? There are no direct answers to such naive questions, but we can develop a proper perspective through an analogy used by Stanford ecologist Paul Ehrlich. In an airplane, all parts are joined together using thousands of rivets. If every passenger traveling in it start popping a rivet to take home, it may not affect flight safety initially, but as more and more rivets are removed, the plane becomes dangerously weak over a period of time. Furthermore, which rivet is removed may also be critical. Loss of rivets on the wings is obviously a more serious threat to flight safety than loss of a few rivets on the seats or window inside the plane. So, this is all about how biodiversity is important to us.